Okay, hi everyone. Welcome to another Wolfram language design review. This is part of our series on language completeness and consistency. And we are about to look at several different things. So we're looking first at subvalues and default values, which I guess I had reluctantly agreed that subvalues should be a documented thing after how many years is it? We had subvalues in version 0.8 or something. Okay. Gives a list of transformation rules corresponding to all subvalues.
Right. So the tentative usage box is what I'm proposing as the new usage box to match how we, match the language on up values and down values.
What do we say about up values? That's not very helpful, is it? That's extremely unhelpful. I mean, this was probably written in wow, it wasn't even in version 1. Weird. Okay, it's a very unhelpful thing. We really should say here, I mean, this is just unfriendly. I think we should use this. I think we should use this thing, values for f of x, blah, 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 etc.
Okay.
And I think we should add something here, paren values of
Right. It's G of F of, right. It's
yeah,
sort
right.
of hard to write because it's sort of G of,
Well, g of f dot dot dot, comma,
well, G of dot dot dot, F of dot 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 dot, right?
I think that's enough. And I think for the subvalues, the thing we should write is f of dot dot dot. What am I doing? Dot dot dot. Right. Like that. Comma, etc. So I think we should do that.
Okay.
Okay. Fine. Default values. Again, I think we should put this in there. I think it's just totally obscure without it. All right. And this is primarily used in pattern matching, right? It's only used in pattern matching.
Right.
I think we should make that very clear in these notes. This is only for pattern matching. It's not the case. It's not going to evaluate to its default value. It is actually, this is wrong. I mean, we should say something like to all default argument values. Right? That's what it is.
Right.
Transformation rule. Wait a minute. Wait. Corresponding to all look, why don't we say corresponding to all values for default of f, which is what this is, default of f, comma, dot, dot, dot. All values of default of f giving default values of arguments of f.
I would say arguments to f.
That's fine.
Okay.
Okay. All right. Onward we go. Graph vertices. Is there an issue here?
Right. So Charles responded saying that he thinks that this is all just because of the bug, which I believe has now been fixed. He can.
Okay, well, let's just verify that and let's see whether. So in the prototype build, Charles, or somewhere else?
Yes, should be in the prototype build.
Okay.
Or the latest master to this.
Well, I gotta re-verify the prototype build. Well, I don't know whether it's worth. It'll be done in a moment. Do you have an example you could create in chat where we could just try this?
Right. So I can send an example. Sure.
Yeah. Why do I have to click on this 17 times to get it to start up? What's going on? This is another. What is going on? Is that? Wait a second. Oh, it's still spinning. Look at that. Something's really wrong with startup for these prototype versions. All right. Okay, what do I do? Should I just say graph?
I just sent.
Is Christopher here? Does he have an example maybe?
I sent an example there.
Okay.
I mean, at least the case I'm talking about was taking his next graph. So.
Well, I guess there's nest graph, and then there was also, are we talking about nest graph, or are we talking about the general stuff about addressing lists of vertices?
I think we're talking about both things. Okay, so what's this? So this is now, that's that. That's that.
But I think your version is probably not the one up to date. The second one should give the first argument, the first vertex should be a list. That's the thing.
Yeah, it preserved the list everywhere else, but not in the first. I don't know if that's a rendering issue or.
Well, let's look. Let's see. Vertex list of that.
No,
yeah,
your
I
build
did the wrong thing.
Yes, your build doesn't seem to have it.
Charles, why am I? Well, I feel unconvinced about all of this. Okay.
Well, oh yeah, that's an old build.
Well, it worked on my build. Yeah, that's old.
Oh, it's like that's like millions of years ago. That's like ancient. Okay. Let's see if my head branch build is any more recent, or maybe my Mathematica as opposed to Wolfram. Oh, great. Should I report this or do I just ignore this? Shall I try it again? Well, that's not encouraging. Should I try the, okay, do you know what build number? So it's the Mathematica build ending in 618, prototype build ending in 618.
I think that should have it. Let me check what my
build I think though that the real, at least the one that I'd encountered before, was the issue where, which I think is more ambiguous, which is there's a usage of nest graph where the function returns a list and where that creates a branch in the graph. It's like there's a documentation example, I think, where you have like, the function list f of hash comma g of hash ampersand. Right?
Yeah, right, which is a very important example for nest graph.
Yes, but I guess it's, of course, it's ambiguous. Do you mean one vertex that is a list, or do you mean two vertices?
Right. Okay. That's yesterday's build?
Yeah, and that particular bug is known and will be fixed in tonight's build.
Okay, so there it's still curlies. Okay, so now let's consider Christopher's case. F of hash. Actually, let me do the I see. So let's be beautiful here. Okay. All right, so that has to work, right? And it does work.
But now what if you, so right, and that is one behavior that you might want, but there's another behavior, which is, right. I mean, if you want to the output is a single argument, a single vertex that is a list. And I don't think it's a bug. I think it's just ambiguous.
Right. So what happens if we do this?
So I think we should get a list of.
It's one.
Yeah, I think we get the That doesn't seem bad. I mean, so long as this is documented, that seems like to get a list as output, you just have to have, its nest graph is going to assume that the outer level list is
multiple branches. And if you want, so you need an extra level of list if you want it to be a singleton list.
Right. Does this solve the problem? Christopher, do you think this
Yeah, I
solves
mean, I
the
think
problem?
that seems like it works. Yeah. I mean, maybe then the other question would be if there's a similar, if that aligns with the behavior of, for example, I don't know, vertex, any of the functions where the second argument is a vertex, like annotation values, an especially hard one. But yeah.
Okay, this is an interesting case. Oh, okay, so it's the same deal basically here. So we just have to document that a list either in the init or in the values, the outer level list. Okay, here's the deal. The outer level list is always a multi, so to speak. But as a courtesy, if it isn't an outer level list, if there isn't an outer level list, it will not produce a bug. It will just assume it's a singleton. Is that a correct statement, Charles?
Yes, and we actually have something similar in the data already. So,
in what?
In the documentation.
Okay. Okay. Well, fine. Should I look at it?
Yep. I think we should just probably show the inner list. I mean, this is a type of example in possible issue in case where someone want to.
But we need to say in the details that it always takes the outer level list to represent branching.
Yep, it's written actually. Should be in the
Okay. But then we should give it an early documentation example under scope or something, or generalization maybe that gives, well, whatever. You decide, you figure it out. Okay. Okay, so now the next question was so great, this is fixed, wonderful. Next question. What about so what was the thing about a graph whose lists are vertices, and then functions that expect a list of vertices? Do you understand what I'm saying? So what I'm saying is, let's say vertex out component. Okay, so let's say we have a graph. Let's say we have a graph here, and let's say we have random integer. Well, let's just do this. Okay, there's our random graph. And now we say vertex out component of that graph, comma. Okay, so let's say 8, 5 here. That would be, okay, that did fine.
So what if you also have the vertices 8 and 5 in that graph?
Right, we need to look at that. But now let me just check that this works. 8, 5, comma, 2, 3. Oh, it's supposed to be a single vertex. Is that correct?
Yes.
Well, I just did an example on my computer where I did give it a list of vertices.
Double %.
Oh,
like,
right. Thank you. Thank you. Yes. Yes.
Yeah.
Okay, fine. So there is a yes, right. So you can give that. Okay, so now let's give our graph where we have a
You just use like vertex add if you really wanted to.
I was just going to do table ij. I goes to oh God, I have to catenate that table. By the way, if anybody can think of a heuristic to decide whether you should be using catenate or whatever. Okay, magnificent. So now I want to do the same thing, vertex out component of that. Oh, 8, 5 doesn't have to be there anymore. So let's do 1, 0.
There's no vertex 0.
I know. But okay, so that's that. Okay, so now let's see what happens if we do vertex 1, 0, comma 1. Not bad.
So the idea is we first take the vertex, we check if it's a valid vertex. So if you are, you're a valid vertex, you take precedence over the list, and then we iterate inside.
Right. I think this is fine. Okay. I mean, you should have something in possible issues for the very, very weird case in which there's ambiguity between a pair. Like I could imagine if you were doing a collection of subsets rather badly, you might have singletons together with the aggregated ones, and that could cause trouble. Does that make sense?
Yes, I guess, yes.
So that's just impossible issues. Okay.
So if you try like 3, 2.
For what? Where?
There's a vertex
in the second
list
argument.
3. Yeah.
Oh, I see what you're saying. Okay, so that is vertex 3, 2, but it might not be.
So is there a way you could ask? I mean, how would you ask for the list 3, 2 and not the vertex 3, 2? That makes sense.
Add the list around.
But it has to be list 3, list 2, right?
No.
No, but the question is, what happens if you want the list of vertices 3 and 2?
Yes.
Yes.
And how can you get that? Do you see what I'm saying? I mean, this
is the suggestion to do map list across that list.
Well, I don't think that's going to work, but
okay.
No, because it is not so.
I think you can't get there from here. I think it's an obscure case and the syntax is not devastating. I think we should just document it. I mean, I'm not thrilled, but I think it'd be good to show examples in which, yeah. I mean, I don't know. What do other people think? I don't see a way to get around this.
Just for fun, can you try list 322?
List 3, 2,
2.
Like that.
No. Double up the 2.
Like that?
Mm-hmm.
I predict this is just going to error out. What else would it do?
Yeah, I guess so. One level of
the outer list.
If I get rid of the outer list, then what that should do is give me the components. Yeah, that will give me the components in this graph. Okay, while we're at it on graph complaining, okay. I would have said while we're on the complaining path and modified that while we're on the complaining graph. Anyway, here's the thing that gets me every single time. I have a directed graph and I do a highlight graph. Let's say, okay, let's take this. Oops, what happened to me here? Oh, I forgot the cat. Okay, magnificent. Okay, now I say, oh yeah, I've got another complaint about placed, by the way, before we forget. Okay, so now I'm going to take a path here. I'm going to say, I don't know, find path of that graph, comma, I don't know, 6, 1, let's say. That's not what I want. So I want 1, 6. Oh, for goodness sake. Where's there a path in this graph? Can somebody just see? Wait a minute. There's a path from 6 to 1, isn't there? Oh, I said 1 to... Oh, it's direct path. I want a path from...
Maybe pick a sparser graph.
Yes. Okay. Let's just do a random graph. Okay. Oh, but I need a directed graph for this to work. So can I do that with directed edges arrow true there?
Yes.
Yes. Okay. Okay. Let's say, oh God, it's probably not going to find a path there. Okay, fine. That's enough. Okay. So now I want to say highlight graph, okay, of %27, comma, and then I want that path. And I say path graph of %28. What the heck?
This path graph of %28 doesn't work. You need to find shortest path. I think it might work.
No, I mean, you probably wanted to say, list 1, 7, 10, and it still will not work, right? Because I think that's what you are trying to highlight, that the path graph will generate on directed graph, where the graph have directed graph, and then we don't highlight them. Yeah.
Sorry, say that again. The path graph will generate a directed or an undirected graph?
Undirected graph.
Why?
Right?
Why doesn't graph highlight graph? If it sees the template of what it is trying to highlight as being an undirected version of the directed graph, why doesn't it highlight it?
We can do that. I think we're just systematic in terms of the second argument should be a subgraph or list of edge or vertex of the actual existing graph.
Right. But so the issue here is a directed edge, does it read on an undirected edge, so to speak? Does an undirected edge read on a directed edge? And no. I claim the answer should be yes.
So maybe the question is, if you gave if the second argument of the highlight graph had, instead of an undirected edge, it had 2 directed edges, one going each direction, then it would highlight them.
We have the case of mixed graph, right? Where you have your graph which can have undirected and directed, and then which one do you want to highlight?
Well, right now, if you do a subgraph, it'll highlight both of them.
I'm not sure I understand. You mean?
Well, the difficulty is, okay, look, right now, this is every single time, it's like, yes. Up a creek, no paddle type thing, okay? Every single time I do this, I get confused. I end up using a subgraph. The subgraph highlights too many edges because I just want the path. I don't want the extra. Sorry, go ahead. Because then what ends up happening is I do a subgraph with those vertices, but that's not good enough because I actually want the graph that is, what is that object? That it is a fragment of a directed graph consistent with a given undirected graph, which is not a subgraph, is it?
Yes, correct. Yes.
So what is it? What is that object?
The path graph?
No. What I'm asking the following question. I've got a directed graph, okay? I then say, okay, one thing I can do is I can say, give me the subgraph of the directed graph with these vertices. Okay, that will be completely different than saying, take this undirected graph with its edges and tell me, use that as a sort of cookie cutter or something on the directed graph and ask what piece of the directed graph, including edges, do I get out from that cookie cutter? Right, that's the question. So, and that's what we're not doing correctly here, so to speak.
Maybe one way we we can still say, maybe we can, set up we can add directed edge to be automatic in this case. And then we say, okay, since the, percent 27, there is a directed graph, we assume what you are giving is the subgraph induced by that.
That makes sense. That makes sense. That the directed edge, where directed edge automatic, where?
For highlight graph.
Is there a way of getting this to work? What I did by just changing the options to highlight graph here?
So just to make sure I understand. So if you replace %28 in that input with the list, 1 goes to 7, 7 goes to 10, does that do what you want?
No, you won't
work. Say graph instead of path graph.
I mean, not the edge, actually. This.
Oh, I like the new pink.
No, see, what you need to put is 1, 7, 10. Right? Because here you infer that the path graph is directed. I think your usual example, you do path graph 1, 7, 10.
Right.
Not with the rules.
Right, because that's a directed path graph that I got
Right.
there. But
So I think there are multiple issues, because I think when you actually run path graph of %28, %28 is a list of lists. It's like a list of paths, not a single path.
Right, that's even screwier.
Right, but this is the case where there is the actual issue, right?
Right, so why on earth did it do what it did there?
Right, because the vertices coincide, but not the edges.
Right. So if you really instantiate this path graph, right, you have a list of vertices 1, 7, 10, and then you have a list of undirected edge 1, 7, and those undirected edge don't appear in %27. That's the thing.
Right, but so do you think you have a solution for this, Charles?
Well, my proposal was to do then, have directed edge of highlight graph to be automatic.
Why would that help? I mean, sorry, I didn't understand. Directed edge
of highlight graph to be automatic, and then from there we'll just look at your
So wait a minute. If I say directed edge is automatic here, does that do anything? Does that mean anything right now?
No, we don't have any automatic.
But do we have a directed edges? So what do we do? What happens if I say directed edge is false? I'm confused about what is directed edges doing in highlight graph?
No, pretty much nothing.
Okay, fine. But so what you're proposing is that if highlight graph, what are you proposing?
Does path graph take directed edges? Could it?
Yes.
Could
it does.
So if you just added directed edges goes to true to the path graph, that would fix the issue for you?
I believe so.
Yes,
yes.
that will fix it, which is the same as the rule above. So.
Right.
So as I was proposing that directed edge automatic, just look at the actual graph you want to highlight and adjust the path, the right-hand side, whatever you put there.
I think that's the right thing to do, because I think people just don't expect, if you say highlight graph, a graph, and all you get is the remaining smile of the Cheshire Cat of its vertices, it doesn't really seem right.
Agree. Yeah.
Right. I mean, I have, I don't have a deep objection, but I am a bit concerned as to then what do directed edges go to true and false mean in highlight graph?
Well, it's a good question. Okay, so what should that do?
In principle, the documentation of directed edge mean how we interpret rules, right? Or how we convert a graph to a rules, directed edge. Or when we want to set a graph based on the input to be true, directed or undirected.
Yeah. Okay. So what does it mean if directed edges is true in highlight graph? What does that mean?
Nothing, because the graph, in this case, %27 take precedence in terms of the interpretation of the.
Oh, so you mean if highlight graph had a first argument that was just a list of rules, then directed edges would determine.
Yep, it should.
Well, okay, so let me just understand something. If I say graph of let's say 1 goes to 2, 2 goes to 3, comma, directed edges goes to false. Oh, I see. Whereas normally, hold on. What does this do normally? I see. It produces a directed graph, and directed edges false makes it undirected.
Right.
Okay, so directed edges arrow automatic in highlight graph. Well, what's that really going to do? I mean, it still has to decide what to do with.
So then we assume the second argument, which should be the subgraph or part of the graph, right? That's, essentially it would be, the subgraph with, directed edge goes to true or directed edge goes to false, based on the type of graph you have on the right-hand side.
Yeah, I understand. You mean on the first argument?
Yes, that's right.
It's a little bit heuristic-y, but it's better than what we do right now, which is just crazy. I mean, it's unclear to me why it does anything. That is, why does the path graph, by the time, I don't understand why the vertices agree. It's one thing to just say, sorry, your graph doesn't match. How can the vertices agree but not the edges? That's my question.
So theoretically, we take the path graph, right? We essentially break it in two parts. You have the vertex list and then the edge list. That's pretty much what we do.
So, but if I say subgraph,
the question is, do you consider a right? I mean, the point is, do you consider a directed edge to intersect with an undirected edge? And I think the answer is, right now, the answer is no. And that might be consistent across all the graph functions, in which case this is probably the right behavior, right?
Yes. I mean,
right, the point is it's highlighting all the places where the two graphs that you've given it intersect. And right now, because directed edges are different from undirected edges, they do not intersect on the edges, but they do intersect at the vertices.
Right.
Right. Do we allow mixed graphs of directed and undirected edges?
Yes.
Yes.
Right. And so then I think we're running into potential problems with this, right? I mean, right, it's very clear right now, even though it may be annoying to you, Stephen, it's the consistent and clear behavior, right? The vertices are the same, but the edges don't match.
Yeah. Well, okay, fair enough. I mean, that's just so weird, though.
I mean, maybe because there's a common case, though, which is apart from path graph, right? There's a common case of just I have a list of vertices representing a path, and I want to highlight that path in a graph. So maybe there'd be some syntax for doing it without using path graph. I don't know exactly what it would be. Right,
well,
but I mean, just like how you can provide a list of vertices, maybe you could somehow.
The problem is a list of vertices, it's just going to say highlight those points in the graph.
Right. My fundamental point is just that the creation of that intermediate path graph is not important in this case, right? All that matters is just that you're basically telling it highlight the edges between these vertices.
Well, maybe
what's that?
Do we need a directed graph path that just takes the list of vertices and creates, does the partition and mapping and application of rule to create?
Well, that's just path graph with directed edges goes to true as an option.
Yeah.
I mean, I don't know. I don't know what this would be, but like if you could have some, like this itself wouldn't work, but if you could have like path graph arrow, directed edges arrow all or something, and the point being that it would highlight the undirected edges and the directed edges and tagged edges and all the edges between these pairs of vertices. I mean, of course, you wouldn't want to do that through path graph, but right. I mean, that's maybe another question is what about tagged edges? So if you have if I say highlight graph and I want to highlight the edge 1 undirected edge 3, and there's only one undirected edge 3, but with a tag, will that highlight that edge or does it not highlight it because technically they're different because one of them is a tag?
Charles, what does it do in terms of matching these up with tags?
That's a good point. In principle, you shouldn't highlight if you don't have the tag, right? Because
Yeah, right. That's right. You basically would want to.
It seems like it's probably the right behavior, but it might also be useful if you could just tell it, I don't care about directedness, I don't care about tags, just highlight this path, just because it's a relatively common case. Again, I don't know what the syntax would be though.
Right, but I mean, but clearly highlighting. What happens if you want to highlight? Okay, how do I highlight only those edges with tag foo?
You can use pattern in principle for all those. So you can do on directed edge, pattern, comma, foo.
Really?
Yes.
So like that.
Yep.
This is a stupid question. That's a dumb edge case, but what if you have a vertex, which is an undirected edge, if that makes sense? Maybe that's a dumb case.
That's a weird case, but it's amusing.
But it's actually happened because, I mean, we encounter it with line graph. Normally, line graph is roughly the dual. I mean, you switch the edge become the vertex, right? And in some cases, you actually want that. So you have a vertex which is an edge, and then an edge. So.
Right. Boy, given all the activities we've had recently, I mean, I have to tell you, we are going to have to do hypergraphs, and we're going to have to do graph rewriting before very long. Just so you know.
Okay.
We've got tons of code for it. It's not like it isn't. It's well explored, and we've got lots of code for it. But it will be non-trivial to design it. Okay, so what are we going to do with this? Are we going to just document this? And I mean, we could document it and find path. We could just show very early on an example of how to display, the path within a graph. That might at least solve part of the problem. Using path graph with directed edge goes to true, but it's not my favorite. It's really not my favorite. I mean, okay, can we think one more round about this? The issue is, when does it care about the annotation of an edge, right? Does highlight graph consider the graph that is matching to, does it require matching of the edge array, so to speak, to decide that it is a match to the graph? Does that make sense? So in other words, it's a graph, this is a graph that almost matches, but doesn't quite. But the very fact that it thinks the vertices match is just what blows my mind. Like, it's not like the graph doesn't match at all. It matches only by its feet, its vertices, so to speak. That's what I find really weird.
Why? Because actually, when you look at the documentation of highlight graph, we didn't actually explicitly say that you can give a graph, right? You give a vertex or edges. When you give a graph, a path graph, it's just kind of a generalization where we instantiate it and then we compute the vertex list, edge list. And
right. Well, then, so we are at liberty in that case to simply decide that path graph ignores directedness.
Yep.
Well, do we know that it's a path graph? I mean, or is there any record of the fact that this came as a path graph?
No.
Well,
honestly, it kind of sounds like the current behavior is the right behavior, but that maybe there should be some other way of some other weird syntax for doing this.
Well, we could make it a little bit, and we could have a directed path graph function. It's a little bit crazy, but not totally crazy. I mean, we have directed graph, and we have graph, and we have, yeah.
I don't think that will solve your problem though, because you can already say directed edges are true. I mean, I think your problem is just that you're going to want to say path graph, and then it doesn't work, and then you're going to have to switch to directed path graph. But you could just as easily just add directed edges are true.
Yeah, but then how do you even know that you have path graph, so to speak? I mean, how do you even know that you have to do path graph? You just give. I think this just needs to be in the documentation for for find path. I think that's the place to start.
Okay.
Okay. All right. What's next? Extract.
Right. Okay, so we
Wait a
have
minute, what was the thing that came up recently? I'm sorry. Well, we said we wanted extract. Oh, yes. I want to talk about placed for a second.
okay.
Placed has ridiculous non-documentation documentation. Let me show it to you. Placed has no example of, so it makes this obscure statement that okay, typical supported forms include, as well as special positions and explicit lists of scaled coordinates. Okay, how does that work?
It's per scenario.
How does it work in graph, for example? Where do I find documentation of that?
Vertex label should have some.
Not looking promising, Charles.
There is label and place.
Well, okay.
I was gonna say, does it? Right, and then the last item in that table is some description of what the numeric forms are.
Scaled position. So that's like an inset.
Yes.
Well, okay.
It's like text. It's similar to text.
All right, I admit it's documented. Okay.
And we've, I mean, actually over the past year or year and a half or something, we've been sort of filling it out in more docs. So if you look at like bar chart, for example.
Okay.
It has nice.
I think it'll be, I hope you have a, oh, it has a diagram. That would be useful. Let's see. Nice. Oh, well, I think that's just what it needs for these other things. Fine. Okay. User error. Okay, there was something we were talking about being extract-like recently.
That was in the lists of vertices, lists and graph vertices discussion.
Oh, which is now over because that was just a bug, basically.
Right.
Okay, fine. All right, so now we're talking about extract itself.
Right.
Incidentally, what on earth has happened to the inserted, the whole business about adding to arrays and so on? The thing that Etienne originally was talking about. You know what I'm talking about? The ability to go, like listable goes at the top level with respect to operators like plus, the ability to go at the bottom level with operators like plus.
I think, well, go ahead, Jose.
Yes, we just worked on something else, but it's still planned.
Okay, fine. It's planned in your team somehow, or is it?
Not sure it's, I mean, I think it requires deeper support probably from Rob for listability things.
Fair enough.
But
who's going to lead it? Is are you involved in that, or is that, do we have
I
to
am
find
involved.
another home?
I am involved, but I don't think we managed to agree on a complete design.
We got very close. I think we
got
should
very
do
close. Yes.
Let's iterate it again and try and nail that design.
Yeah. We will.
It's a really good thing. It'll be very useful. Like splice, like nothing, and so on. These are very useful things.
Mm-hmm.
Okay. Part specs in extract. Extract is the inverse of position. That is axiomatic, we claim. Right? Okay, so what is the point here?
Okay.
Go ahead.
Right. So right. The point is that, people have, wanted things like all in extract, but all obviously is something that would never be returned by position. And so, we've had sort of some inconsistent support, not documented. And now we have a branch where it is sort of consistently implemented.
So this is a review of that supposedly consistent implementation. Is that correct?
Correct.
Okay.
Right. So, and, there are a couple of issues mentioned there, and I've also added a tentative note to the documentation.
Okay. What is part? So part with that mat. If I just take that matrix and I say part all comma 1, then I get that.
Yep.
And normally extract would, I'm very confused by something. If I say here, extract this comma 1 comma 2, right. That's what I would expect. Okay.
Yep.
And in order to get the thing that I was thinking I was getting, it will be this.
Right. Yes.
Right. Okay. First and third columns independently. That's nice. I mean, is there any problem with that? That seems like the right thing.
Yeah, I don't think so.
Okay. This is
right. So
okay.
since it's not a list of lists, it's treated as a single, part spec. And so this is doing the same thing as you would get as part of mat, comma all, comma list 1, 3.
Okay. So if I were to do that as mat all 1, 3, I will get the same thing. Good.
Yeah.
Okay. So now if I were to get, if I did 1, 2, oops. Okay.
Right. And now if you gave that in a list to extract,
it's going to get confuzzled.
Yes, you'll get something different.
Interesting.
Right, because you gave it a list of
No,
position
I
specs.
understand why it happened.
Mm-hmm.
Anybody have comments here? Is Christopher still here? Does he have a comment on this?
I'm here, but I don't have an immediate comment.
Does it horrify you that they're different?
A bit, yeah.
Well, it's because part accepts list of indices.
I know.
And
I know why it
that's
happened.
the reason. Yeah.
I mean, I think it's one of these cases where there is going to be a corner case that's a little bit horrifying, but on the other hand, it's probably the right thing. It's probably useful. Okay, so that's one weird thing, and that should be documented in possible issues, presumably.
Right.
No, it's actually it's logical.
Of course, it's logical.
No. I mean, it's not a possible issue. It can be documented properly as a. Because
my plan is both to document it under properties and relations as a positive, and also
as a possible issue that it's different.
Right.
The fact that it's different is a possible issue.
Right.
Okay. So now what's this?
I mean, this is basically the same issue. I just, instead of all, I wrote the list 1, 2, 3.
Oh my gosh, that's a more horrifying case.
Right, now you can get it to work with an extra level of list, right? Because then you have a list of lists and it looks inside of each list as a sequence of part specs.
I understand.
Now, this confusion that we are seeing here has always been there. Now, this particular case, the list of lists, is the main purpose of extract. So
I know.
This is what position could return. It's the other cases that are bringing extract closer to part and that are a bit strange in there. But they have been always there. What we have done here is simply to be more consistent, because some users had complained that, for example, MapAd had a more extensive support of this language, which is correct. And so now extract is closer to what MapAd can do.
Right. Yes.
So
and I think-
MapAd and extract are consistent.
Now they are closer. In fact, I think we have made in this branch extract to be even more powerful than MapAd.
Okay,
Yeah.
so what's the thing that extract can do that MapAd cannot do?
Well, I personally, I think looking at it, I think it's a bug in MapAt. So in MapAt, if you have like a number and then a list of numbers, it works. But if you have it in the other order, it doesn't, I think.
Number and a list of numbers. I see. Okay, fine. So that should be looked at. Okay, but so then
Right, but this-
position, anything
right.
position returns, extract can eat, and so
Yep.
can MapAt.
Mhm.
But extract has some additional conveniences that are beyond what position can return.
Correct.
Okay. And it has a different behavior because it isn't varargs, among other things, from part.
Correct.
Okay. In terms of, I mean, in terms of its sort of outer producting behavior, so to speak.
Right.
Okay. I don't see
Right,
a problem
if-
with this.
Yeah, if you give it a list of lists in the second argument, then you would get the list of parts where you turned each of the inner lists into a sequence to give it to part.
Yep.
So.
Right. You got that list of parts. I think we're good here.
Okay, there is one issue which is sort of an implementation issue, so it's really a do we care, which is up till now, extract has supported, one dot and just sort of cast it to an integer. And now that's been lost. And so the question is, how much do we care?
I think
Do
it's
we-
unbelievably frigging weird that it worked.
Okay,
I would never have expected that to work.
okay.
I suspect that worked because of some, avoidance of some issue with the compiler or some other weird thing like that. Does anybody else here? I mean, if you'd quizzed me, would that work? I would have said not a chance. Anybody else disagree?
No, I was very surprised to know that too.
Part support that.
What?
It extract supports floating point because part supports floating point.
You can't be serious. After all these years, like if I
ABC
say
1 point, yeah.
Right.
Really?
Now, I
It
think if you
should
did
be
like
there.
2.1, it would yell at you, but the special case of 2 dot. And so I'm a little bit worried about breaking user code.
Yeah, that does seem a little concerning. I mean, I would have no idea that this would have worked.
Right. And I'm wondering if it's because, if you're inside of n, then maybe your numbers.
Oh,
Yes, right. Better not break that. I mean, I hope it isn't even documented.
It's not. All right. Well, we'll try to fix it, and
Okay.
just to not break user code. But there was no plan to document it.
Okay. Okay. Boolean operators treat 1 and 0 symbolically.
Right. So if you do 0 or 1, you get 0 or 1, and if you do 0 or true, then
just
you get
get-
true.
Right.
And
Right.
if you
Right.
get
0, 1 are not things of the Boolean world.
correct.
Okay, but Boolean table of, let's say, an OR of AB, comma AB. Is that how it works?
You have
I think normally you would put the
you put parentheses around AB. I'm not quite sure how it works this way.
make it a
It should be
list.
list AB.
Okay. Okay. So now what is the proposal here?
Well, so you and somebody else complained about the fact that if you put 0 or 1 instead of A or B, in that expression, it still returns the same result, which I think is a little weird, but I don't. Yeah, so you reported a bug, and
what was my bug?
Right, so it's replace all the A's and B's with the 0 or 1 in that Boolean table expression.
This with 0, 1 here?
Yeah.
Yeah,
That's weird.
it's just a
And
variable. It's just
right.
a variable to Boolean operators.
Right, and I agree that's weird, but I you know, of
How
all
do
the
I
things I
turn
could.
Yeah. How do I turn the true, 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 false into 1, 1, 1, 0? Is it an inverse bool?
Bool, yeah.
Well, that's not too difficult. Is that documented in Boolean table? You should document it there.
I think it is, yes.
Oh, there you go. Well, okay. I think I probably retract any comment I had there. I think we're good here.
Yeah. So the only inconsistency here is that Boolean function actually treats 0 as false and 1 as true. And it's absolutely the only Boolean operator that does that.
I'm sorry, Boolean function does what?
So if you do like Boolean function of 3, 2, which is some Boolean function with 3 variables, I think, if I correctly remember the order, or with 2 variables, and now you evaluate it at 0, 1, it would actually give true or false. So it will treat 0 as false and 1 as true.
Right. Right. Well, yes. If you do
and why
Boolean,
shouldn't it? Yeah.
Right. If you do Boolean function of 2, 7, which is or, which I know because I checked that last night, then right. So if you do a table with 0 and 1s, then right. So do
that's crazy.
say
yeah, I understand what you're doing. I understand what you're saying. If the ij is 0, 1, it'll do something crazy. Tough tables.
If the ij is 0, 1, it'll do the right thing. But if it's a 1 and 2, then it won't evaluate.
Or it will treat 1 as true, but 2 is something unknown.
Why doesn't that do anything?
Well, it's not simple. Boolean convert will convert it to explicit formula. I mean, Boolean function has leaf count 1.
I see. Why does it convert it to not A or not B?
Oh, did I
well,
have it
that's
backwards?
I guess that's the
oh,
the function.
Yeah, maybe I did maybe I had 0 and 1 backwards when I did my table.
Okay.
But yeah, so if right, but the point is, you can give it 0 and 1 and it'll behave as if it's false and true, I guess. Right, 0 is false, or is 0 true?
0 is false, 1 is true, but
right.
All the other numbers are unrecognized symbols.
Okay, look, I think what it's doing here as a courtesy, having Boolean function work with 0 and 1 is a good thing. The insanity of having a Boolean table where the names of the variables are 0 and 1 is an insanity and shouldn't be worried too much about.
Okay.
Now.
Also, I see that it's documented that Boolean function works with 0 and 1. And also you might imagine if we wanted to support like higher valued logic with Boolean function, like 3 valued logic or something like that, then it makes sense for it to take numbers.
Exactly. And I mean, for example, Boolean function is consistent with cellular automaton.
Right.
And cellular automaton can take obviously more than 2 valued. I mean, I wonder whether that's something Boolean function.
There are some notes about
that probably was the original reason why we put it there, the 0 and 1 to be consistent with cellular automaton.
Okay, there we go. So cellular automaton n, 2, r is equivalent to that Boolean function. Right. So in principle, we could provide a Boolean function with k greater than 2. And it's completely obvious what it should do. Is there any way to actually add that in? What is form here? What's that form argument?
Is that things like BNF or?
Oh, it automatically converts to the forms that are specified in Boolean convert. So it's sort of a shortcut of not writing Boolean convert.
Right. Well, in a perfect world, we would add, we could put it as a long time, we should add the case for higher valued logic someday. But let's not worry about that right now. Okay, comments on our live stream. Point from Rafi about could part have an operator form. Sadly, part is Verilog, so it really can't have an operator form. But extract does have an operator form, right?
Correct. I didn't list any here, but it's documented, and I'll make sure that there are appropriate examples.
Fine. And Dan or Dane, hard to parse with different number of vowels, suggests adding a second argument to bitnot that specifies the size of the integer, i.e. bit XOR. I think we oh yeah, this is a whole can of worms. This is a whole horrifying can of worms associated with the representation, 2's complement arithmetic versus other things. I agree that there's an issue here with an unlimited number of digits. So the question is, could we add a thing which gives the number of digits? Everybody is very silent.
Well, I
think it would be useful.
What's that?
I think it would be useful.
Okay, well, so then why don't you see if it's easy to do? It may be totally trivial to do it. Are there other functions for which that would be relevant? I don't think so. I think bitnot is the only one which cares about the word length, isn't it? But XOR doesn't care. It's just a local operation on aligned digits.
No, right, but it knows how it needs to know how many leading zeros to negate, doesn't it?
No, that's bit XOR doesn't negate anything.
Well, okay, right, but I was thinking. Oh, we.
I see what you're saying. You're saying the alignment. Well,
right.
what I'm saying is that the alignment. I think bitnot is the only one that cares, because I think all the other things we support, because we don't have a general bit function for arbitrary. We could have bitwise Boolean function, and then we would have this issue for everything. But right now, the only one we have is bitnot. That's the only. Don't some of these?
Right. Yeah, you're right.
But bit shift left must have an issue. Maybe
right. So bit shift left takes the K argument, which is right.
No, that's how many places to shift by. The point about bit shift left is that in principle it could shift a digit out of the word.
Mm-hmm.
Right, that would be a case that could happen. But bitnot is an in-your-face example of where it cares about the word size.
Yeah.
This one also cares about the word size potentially. Both, it's worth just doing a quick look at them and see whether it's easy.
Okay.
To do this. Did we get through our agenda?
We did.
Amazing. Good stuff. All right. Well, that should be it for this.
Thank you.
Thanks, everybody.